So today we're building functions out of functions. There's 4 algebraic ways to do this that we're going to talk about, and these ones are super, super simple. So if you ever see something that looks like this, f plus g or a plus b of something else, I would pronounce this f plus g of x, and what it means is to take your f of x function and stick it next to your g of x function and put a plus in between. You're literally just adding 2 things together. So we're going to kind of jump around here. Down a little further down the page, we've got an example of 2 functions, and they're asking us to find f plus g of x. So I'm literally just going to take those 2 functions and substitute into this expression where they're being added together. One of them is 2x plus 1. One of them is x minus 2. We'll simplify if we can. We would end up with 3x minus 1. For f plus g. So again, a lot of what we're going to do is just going to be fancy substitution today. All right, f minus g of x, same idea. We're just going to take those 2 functions, f of x and g of x, and we'll subtract them from each other. The parentheses become important when you do this. I'm in the habit of, when I do substitution, I always draw the blank parentheses first. I kind of fill out the format, and then I go back and write what's going to go in there at a later time. I sort of split the thing up into 2 separate tasks so I can make sure I don't accidentally copy something down wrong while I'm trying to remember the overall format. Simplified correctly, this would be, 2x minus x is x. 1 minus negative 2 would be plus 3. All right, so far so good. Awesome. Fg of x just means multiply them together. F of x times g of x. So down here, we're going to just write our 2 functions next to each other inside of parentheses, and we'll multiply them out. See if we can simplify anything. FOIL. Let's see, that's a negative 4x and a 1x. Negative 3x minus 2. I'm using some FOIL shortcuts to come up with that final. You guys are all familiar with FOIL, I assume. I mean, no, that's one of those things that we won't go over in class, but I'm happy to sit down with you one-on-one and go over it with you. And then finally, f over g of x just means divide them. F of x over g of x. So in this case, it's going to look like this. All right. Can I cancel these 2 x's? Can I cancel these? I love that you're saying factor. That's kind of the key thing. What are you allowed to cancel in a fraction? You are allowed to cancel sometimes in fractions if you have 2 things that match, but those 2 things must be what? They must match each other, yes, but it's not just anything that matches, because this x matches this x. Like if I had 3x plus 5 over 3x minus 1, 3x and 3x can match, but I can't cancel those. Absolutely not. The only way you can cancel 2 things in a fraction is if they are both factors of the numerator and the denominator. Okay, so I could not cancel the 3x's here, but if I had like 3x times x plus 1 and 3x times 2x minus 7, I could cancel those 3x's because this 3 and this x are factors of the numerator and this 3 and this x are factors of the denominator. They're multiplying by everything else inside. If it's just adding or subtracting, you cannot cancel. It's got to be a factor. It's got to be multiplying by everything else. That's going to become important in chapter 2, but it won't affect us too much right now. Okay, we feeling okay about that? All right, here comes the FOG of x. Did you guys see this notation last year? I don't like this. I wish they would just write it this way. This makes more sense to me, and I'm going to always use this. I like this because it literally shows you from the notation what you're doing. The idea, I tried to illustrate this with some block diagrams, but the idea is we're used to a function being something that we take an input and we stick an input in and an output comes out, right? X goes in, f of x comes out. If I've got a different function, g, I could stick the same input into it, but something different might come out. The whole idea of f of g of x is that we're going to take two different functions and link them together so that we put our input x into one of them, that spits something out which goes into the other one, that spits something out which comes out here, right? So cow comes in, g turns it into a hamburger patty, and f turns it into a cheeseburger. Okay, so it's like two different machines on an assembly line that are coming together to turn cows into cheeseburgers. We use that example a lot in this class. Just wait till we talk about inverses when the cheeseburgers go in to the backwards machine and it turns them back into a cow. That's pretty magical. But you get the idea, right? We are putting something into one and then into the other. Now, what's kind of counterintuitive to me about this notation is when I say f of g of x, x is actually going into the g function first, and then that's going into the f function, which is sort of backwards. When you read this, it kind of feels like it should be going into f. To me, anyways, it feels like it should be going into f first and then into g, but it's not. So the thing that helps me the most with this is if I can remember to work from the inside out. X is the input, so we're going to start with x, and then we're going to work out to g of x, and then once we get something for that, then we'll work our way out to f of x, okay? But when we have f of g of x, x is going into the g first. It's closest to the g in the notation. It's going into the g first, and then into f, and then out. So we're going to use these two functions, and we are going to find f of g of negative 2. So we're going to work from the inside out. I will start by finding what is g of negative 2. And you guys have been doing stuff like this since Algebra 1, so go ahead and do that on your own paper. G of negative 2 is, well, it's the g function, which is x squared plus 4, and we're literally just substituting negative 2 into that. The name of the game today is fancy substitution. Negative 2 squared plus 4, which would be 4 plus 4, which is 8. Now that's not our answer, that's just the innermost part of it. G of negative 2 is 8. So what I'm going to do now is I'm going to rewrite this, but I'm going to leave the g of negative 2 out because I now have something I can substitute in for g of negative 2. What is g of negative 2 equal to? It's equal to 8. So I started on the inside, I put the negative 2 into the g function first, I got my answer, it was 8, and now that 8 is replacing the g of negative 2. Now the 8 is going to go into the f function, and then we'll be good to go. So let's find f of 8. F of 8, where's my f function? Here it is. It's the square root of x plus 1, so this would be the square root of 8 plus 1, otherwise known as the square root of 9, which is 3. So f of g of negative 2 is 3. Nope, the only time we do plus or minuses with a square root is if we're solving an equation using a square root. So this situation here where you've got x squared equals something and you're going to take a square root on both sides to solve. Yep. That's 3, yep. F of g of negative 2 is 3. And keep in mind, what did we do? This is taking an input of negative 2, sticking it into the g function, which gave us 8, and then that becomes our input for the f function, which gave us 3. All right, we feeling okay? Let's do another one. Let's start with inside out is the way to go with these. So I'm going to start by finding f of negative 2, and then I'll take that answer and I'll put that into my g function, and then we'll be good. That's it. So finding f of negative 2, my f function is the square root of x plus 1, so I'm plugging negative 2 into that, and we just broke it, didn't we? We just broke the machine. We stuck something in there wasn't supposed to go in there. So when we deal with functions, we're not dealing with imaginary complex functions in this class. Functions will be strictly real numbers. If we ever do something, if we ever put an input into a function and we get a complex answer out of it, we're going to just say that doesn't exist in our function land. So we're going to say this is undefined. So the answer to this is undefined. I can't do it because I can't even put the -2 into the first function and get an output, let alone then take that and put it into the second function. Yes? We were not, those were not function problems. Yeah. So we will, when we deal with polynomials in chapter 2, I should say, we will get into roots and zeros of functions. Okay? And those are going to have imaginary parts to them. Yes. But when we deal with, there's no place in this class where we will put an input into a function and get an output of an imaginary number. Yep. Those functions do exist, but not in our class. Okay, I want you to keep this in mind. This is going to become important in a moment. I'm going to ask you a question about going back and looking at example 2. So let's put a star next to this and move on. All right, example 3, notice that these are the same two functions that we were just dealing with a moment ago. That's important, or it will be in a moment. In this example, they want us to find f of g of x. Now, when we do this, we're not actually putting a specific input into it and coming up with an output. What we're doing instead is coming up with a shortcut so that we don't have to keep going back and doing that two-step process anymore. Okay, so the answer to this is going to be another function. It's going to be another equation that would give me the same answer that we did just a minute ago if we just put it into that one function. So when we do this, we're finding a shortcut. And this happens all the time in the real world. When people have very complex systems, they will find a way to model what all of those systems would look like as one single thing squished together so that they don't have to model all these individual things. Anyways, let's do this. So again, keep in mind, we're not going to get a numerical answer. We're going to get another equation, another function. So we are going to work from the inside out, just as we did. I'll show you my favorite way of doing this. I will always start by rewriting f of g of x equals. And just like before, I'm going to start from the inside out and try and substitute stuff in. Now, they didn't give us a value to plug in for x, so I'm not going to substitute anything in for x. My next biggest thing, working from the inside out, is g of x. So I'm going to rewrite this and leave out the g of x. I'm going to substitute something in its place. And what do we got that we can substitute in for g of x? X squared plus 4. And then we're going to do what this says to do. Now, back in Algebra 1, if I asked you to find f of 2, you knew that you would just take 2 and plug it into the f function, right? Same thing here, except instead of plugging a number in, we're going to plug this whole expression in for x, okay? So just like before, let's go ahead and write out what the f function was. It's a square root of x plus 1. But I left out my x because I'm now going to replace my x with x squared plus 4. That's not that bad. And then we'll simplify it if we can, and we can for this one. It is, that would be x squared plus 5. Is that the same as x plus root 5? Must not be, because I wrote it on a piece of sticky note and not on the paper, so I didn't have to erase it later. It absolutely is not. My gosh, I wish that you could split up addition inside of a square root into two separate square roots. Man, that would make so many things in math way, way easier, but unfortunately it just doesn't work. It just does not work. So we cannot do that. Anytime you have addition inside of a square root, you cannot split it up into two separate square roots. People want to do that all the time. It just doesn't work. My favorite example of that is this. What if I asked you to do the square root of, see if I can remember this. Oh man, I'm totally not going to, here we go, 64 plus 36. Is that the same as the square root of 64 plus the square root of 36? Is that the same? What's the square root of 64? 8. And what's the square root of 36? 6. If we could do it this way, the answer would be 14. But 36 and 64 is 100. The answer is 10. It's not 14. So this is not legal. I can't split it up into two separate square roots because sometimes, at least sometimes, if not all the time, I'm going to get different answers when I do it that way. When I stick numbers in there. All right, so we're uncovering some misconceptions because we're going to be tempted to make these mistakes later. Okay, now check this out. This is cool, okay? I want you to take -2 and plug it into this function. Plug -2 into this function. You don't have to write anything down, just do it mentally. What would you get if you plugged -2 into this function? You would end up with a 9 on the inside, and you take a square root of it, and your answer would be 3. Wasn't that easier than what we did here? So here we had to do it in 2 steps. Now, if I asked you to go back and find f of g of 7, would you rather do it in 2 steps like this, or would you just rather plug 7 into this function and be done with it? I'd rather just plug 7 into this. And you're going to get the same answer either way, because that's what this is. When we do f of g of x without a number, we're coming up with a shortcut that would get us the same answer as if we'd done it in that 2-step method that we'd done before. Okay, so that's the power of doing this. This is why we teach this, because this happens out in the real world, especially in a lot of programming and engineering applications, where you're going to take 2 separate systems and combine them into one just to make things more efficient for you. Yes? Yeah. No, that's a great question. The question is, on a test, if part of your work is to do this, and then I also asked you to do this, am I expecting you to do it the long way, or is it okay to use the shortcut? Absolutely use the shortcut. Show me your steps, show me your work. But if you can make that connection and be more efficient, then that's great. Yeah. We'll talk some test-taking strategies when we get there, and being efficient is important in this class. Yeah. That's where, again, it's important to make sure we understand things really well. Before we go on, let's talk about the domain of this. So this is our answer, but they also said, and its domain. So let's find the domain of this function. Just to practice, we've been practicing finding domain of functions algebraically a whole bunch. What would my restriction inequality look like for this? See if you can write that down for me. It's got a square root with a radicand of x squared plus 5. You should be able to write me a restriction inequality for that. Anything inside of a square root must be what? Not positive. Greater than or equal to 0. Positive or 0. So tell me, what values of x make that true? -1 works, yes. That is 1. Can you give me all of them? We don't want to sit and list them individually. That would take forever. I like your answer, though. Is it all real numbers? If I solve this, if I did -5 on both sides, would it always be true that a number squared is going to be greater than or equal to -5? No? Can you give me a real number that I could stick in for x there that would make that false? What if I put 0 in there? Is it still true? Yep. What if I put 1 in there? Is it still true? If I put -1 in there, is it still true? Yeah, because -1 squared is going to turn out positive, which has to be bigger than -5. What if I put a really big negative number in there? Is it still going to be true? Yeah, I think this is always going to be true. It's always going to be true. So yes, the domain is all real numbers. We're going to write that as -infinity to infinity. Because this always has to be true. If I square a number and then I add 5, it's got to be positive. The smallest thing that x squared can be is 0, but then I'm going to add 5 onto it, so it's still going to be bigger than or equal to 0. Okay, so there's our domain. All right, we're going to go backwards now. So I want you to do this on your own. Follow these same steps. Start by writing g of f of x, and then rewrite that, but pull out the smallest thing that you can replace with something else. We can replace f of x. So pull the f of x out and replace it with something, and then do that substitution into that G function. And I'd like you to find the domain for that as well. F of x is my G function is x squared plus 4. And, ooh, that's convenient. How'd you do? If you're still in progress, don't peek up here just yet. Keep going. You got this. You got this. Fancy substitution. We doing okay? So I'm guessing we got x plus 5. Any questions about x plus 5? What's the domain of x plus 5? I can do any. I can put anything out. There's no square roots. There's no fractions. It's yeah, whatever is fine. It's a linear function. We can plug any number we want into a linear function. Except well, I'll let you read the big question that comes after this. So I mentioned a moment ago that we were going to come back to example 2. And if you read the big question, it's kind of hinting that there's some contradiction between this answer that we just got for example 4 and the answer that we got for example 2. So I want you to take a moment and compare. Now, this is an opportunity for us to make sure that we truly understand all of the pieces of what we're doing today. What does it mean when I say that the domain of this function is all real numbers or negative infinity to infinity? What does that mean about g of f of x? What does it mean about this thing? It means that I can put anything I want in for x. That's what it means. It means the input, I can put anything in I want for x, and not only that, I'm going to get an answer out of it. Okay, but that contradicts what we got in number 2, because in number 2, weren't we dealing with g of f of x? And we put a number into it, but we did not get an answer out. Now, I'm confident that what we did here was correct, which means there must be an issue with our domain. Okay, and this is the only hitch to this whole thing. So all of this g of f of x and f of g of x, it's relatively simple. It looks kind of complicated, but once you've done it a couple times, you realize all I'm doing is just substituting something into something else. And maybe doing that a couple times. But the one thing that's complicated is when you start talking about the domain of g of f of x. So the thing that does not work is that in example 2, we tried to find g of f of, what was it? Negative 2. And it was undefined. But in example 4, we came up with a domain that stated, I can put anything I want into this, and I'm going to get an answer. So those two ideas conflict. So what's going on? What's going on is that sometimes when we create these shortcuts, and remember, this is just a shortcut. Sometimes when we create these shortcuts, we lose information about the individual pieces that are inside. Right? So this is a shortcut that's telling us this giant factory. This is an equation that describes the entire factory, but we've lost some information about the individual machines inside because there's something special about this machine. This machine can't take anything we want into it, right? This machine's going to break if I put numbers like, well, negative 2 into it. Okay, and when we came up with this shortcut, we lost that information. So there's So we need to fix this. This is not the correct domain. To fix this, what we're going to do is we're going to look at the domains for f of x and g of x. You've got it further up your paper, but I can't see it on the screen, so I'm just rewriting what f of x and g of x are. And let's find the domain of these individual machines, and then see if we can use that to modify. So the domain for f of x, the work for that would be to take the radicand and apply your inequality to it. What must be true about x plus 1? It must be greater than or equal to 0, which means that x, in order for this machine to function, our input x has to be greater than or equal to -1. That's why -2 didn't work, because it wasn't greater than or equal to -1. So our domain for f of x is anything from, that's not a parenthesis, it's a square bracket, anything from -1 to infinity. Again, that's why -2 didn't work, because -2 is not part of the domain. If I try to put -10 into this function, it's not going to work. Okay. G of x, the domain is whatever, right? Everything goes into this. So the domain for this is -infinity to infinity. G of x is a nice machine. It's not going to break. It'll take anything. F of x is a little sensitive. Be careful what you put in there. Okay, and then what we have to keep in mind is that when we do this g of f of x, we talked about this a minute ago, which machine is x going into first? It's going into the f machine first. So g of f of x, the domain of g of f of x can't have anything in it that's going to break the f of x machine. And that's kind of the big idea of this, okay? So this rule's down at the bottom of the page. These examples that kind of contradict themselves kind of lead to this. If you're going to go ahead and find a shortcut for a composite function, a of b of x, your domain can only include the values that are also in the domain of whatever that innermost function is, b of x. That's the rule. So knowing that rule now, we can go back up and fix our domain in example 4. So I'm going to scroll up here. Are we good? Give me the sign if you need a second. Going back up. So when we looked at this, we said, okay, this is a great shortcut, and it seems like the domain would be all real numbers, but what we should have done is gone back and say, well, it's going to be all real numbers, but we also have to throw out anything that's going to break the f of x machine. All right, so f of x, just this part has a domain that x is from -1 to infinity. So if I overlap this domain with this domain, that'll get me my overall domain, which is -1 to infinity. So our overall final domain for this function is going to be -1 to infinity. It seems like this should have a domain of all real numbers, but we got to keep in mind that part of this process is putting an input into a machine that can break. We got to think about what can break it. All right, so that's a lot of words. There's a lot of concepts floating around. Let's do some concrete examples, and then we'll circle back and see if there's any questions, okay? So we're going to kind of take all of this into account as we do the examples on the next page, and this will be like what you do in your assignment. And these last few examples will be it for us for today. And there's a chance that we may be rushing at the end of the period to do examples 7 and 8, but I put those last because they're the easiest thing we're going to do all day. When you see the answers to those, you're going to be like, oh, this is so easy. You'll be looking forward to doing those on your assignment. All right, so let's do this. Okay, so my goal is to find a shortcut that would tell me in a single equation how to take an input, first put it into the G machine, and then put the output of that into an F machine. But I want it in a single-step equation instead of having to do it in 2 steps. That's what we're doing here. Okay? And then we're going to do the domain of it. And since I know I want to find its domain, before I even get started, I'm going to start by looking at the domain of G of x. Because I know that anything that breaks G of x is going to break this whole factory, right? G of x is the first machine our input's going into. So we got to make sure that anything we put into the factory isn't going to break the first machine. So let's look at g of x here. And what do we notice about g of x? Ooh, it has a denominator. And the denominator of a function must be not equal to 0, which means x can equal to -1. All right, so the domain for just for g of x is x not equal to -1. So we're just going to keep that in the back of our mind when we eventually come up with our shortcut function and we start looking at its domain. If -1's allowed into that, we just need to toss it out. We just need to exclude that as well, and then we'll be good. Okay, -1's the only number that can break, the only input that can break that g of x machine. So now let's go through the steps and actually do f of g of x. So I don't have a number to put in for x. That's my innermost thing. So I'm going to put something in for g of x. What can we substitute in for g of x? We could substitute in 1 over x plus 1. And then what does that say to do? That says to take my f function. Let me rewrite my f function without the x in it. The f function was x squared plus, or minus 3 rather. I left my x out though because they gave me something to substitute in. I'm going to substitute in 1 over x plus 1. And we'll see if we can simplify that. In a fraction that's being squared or any exponent, do the exponent to the top. 1 squared is just 1. And then x plus 1 squared, and then minus 3. And I could expand this out. That would be what? X squared plus 2x plus 1. There's a shortcut for that we'll talk about later on. But I think I'm just going to leave it like this. We'll call that good. Any questions? Do you have a question? We're good? Okay. All right. So let's find the domain of this. So this is my shortcut, right? So at this point, if I said, go ahead and find f of g of 7, what would you do? You just plug 7 into this thing. And if you wanted to check it, what could you do? Well, you'd plug 7 into this, get an answer, and then take that and put it into this and get an answer from that. And it should match up to the same thing. Okay. We could do it in 2 steps by putting 7 into this first, using the output of that to put into this, or we could just put it into this and be done in 1 step. All right, now, so the domain of this thing, what's the domain? I see fractions. What's the deal with fractions? The denominator cannot equal 0. So denominator cannot equal 0. And we're going to keep in mind that after I solve this, we might have to toss out -1 as well if it's not already part of it. So we'll square both sides to get x plus 1 not equal to 0. We'll subtract 1 on both sides. X not equal to negative. Interesting. We got the same domain in this as what we had originally for my innermost function. Okay, that happens sometimes. So did I need to worry about this? If I'd forgotten about this at the beginning, would it have caused any issues? No, not on this one. So sometimes you can forget to do this step and it doesn't make a difference. So this is my function and its domain is x not equal to -1. So the domain would be -∞ to -1 and -1 to infinity. All right, we'll pause here for questions on that one. All right, ready for, it's basically the same thing but backwards. This was g of f of x. So we'll do the same steps here. We're going to first, since we know we're eventually going to find the domain of the whole thing, let's find the domain of that innermost piece. We need to make sure that any input we put into this factory isn't going to break the machine that it's going to hit first. So f of x has a domain of, what's the domain of this thing? It's everything. Yeah, anything works there. So the domain of this is all real numbers, -∞ to infinity. So whatever I get for my domain of the other one, we don't need to chop anything out of it. It'll be good to go. Go ahead and just take a moment and practice going through the steps of finding g of f of x. You're going to start by substituting something in for the most innermost thing you can, which is f of x. And then we'll do our g function to that. What was our g function? It was 1 over x plus 1. It should be a 3, shouldn't it? I'm having a hard time reading my own handwriting. That's terrible. Thank you for the correction there. That simplifies x squared minus 2. Hey, sweet. If I asked you right now to find g of f of 2, could you do that pretty easily? You plug it in there. What would you get? G of f of 2. I'm getting a half also, yeah. Yeah, that's great. If I'd done it the long way, I would have had to put 2 into this first. If I plugged 2 into this, I would get 4 minus 3. I'd get an answer of 1, and then I'd put 1 into this one. And I get a half, which is the same thing, but I had to do it in 2 steps here, where here I was able to do it in just 1. Awesome. Let's find the domain of this thing. It's got a fraction, so it looks like x squared minus 2 needs to be not equal to 0, which means x squared needs to be not equal to positive 2, which means x better not be root 2 or negative root 2. If this is difficult for you to translate from x not equal to these two things to here, remember something that makes it easier for me is to make a number line. Put those 2 open dots at negative root 2 and root 2, and then look through and write your intervals down. Sometimes it's easier to see if you graph the number line. Some of us are probably getting to the point where we don't have to do those graphs for everyone. On a test, I would do it for everyone, personally. All right. You guys want to try one? Yes, we can't wait to try it. Hey, what? Hey, I got an idea. We know we're gonna have to find the domain for both of these, so let's go ahead and do that right now. What's the domain for 2x squared? Everything. And what's the domain for g of x? I don't know. X plus 2 needs to be greater than or equal to 0, I know. So I guess x needs to be greater than or equal to negative 2. Is this the same problem we did before? On the last page? It's not, is it? No. Okay. Good. All right, so we got f of g of x. So we do need to make sure that in our final answer, we only include the part of the overall domain we get where x is greater than or equal to negative 2. So a bunch of fancy substitution. What was g of x? What was this? And that was 2x squared. And x is now x plus 2 roots. Yeah. Hey, how's it going, Jamin? Good. Good to see you. Take care. Did I make any mistakes there that you guys are seeing? Okay. Now, I might be tempted to say that the domain of this is all real numbers, except I remembered there's more going on to this. All right, so this actually came from two separate functions, and one of those functions couldn't have any inputs where x was -2 or less. So the domain of this is all real numbers. If I combine it with the domain of this, the domain is going to be x greater than or equal to -2. So -2 to infinity will be our overall domain for this. All right, g of f of x, I feel like, do we need to do that one? Probably should for completion. Yes? Right here? I would need them there because when I multiply this 2, it needs to be multiplied by everything in there. Yeah. That's why I kept them there. Good question. You know what? Let's go down to the last two examples so that you can see these. Okay. Hey, when I first saw this in the textbook, the instructions may look a little bit different, but it's going to say something like rate is a composition of functions. So they're going to give you an equation with x's and y's, and they're going to say rate is a composition of functions. What they're asking you to do is write an f function, f of x equals, and a g of x equals, so that if you were to do f of g of x, it would turn into x minus 7 squared. Okay, all you got to do is come up with two equations here. So they're kind of giving you the answer, and they're asking you to come up with the two questions that if you put them together, you would get that answer. Does that kind of make sense what they're doing? And when I was looking at this, I was like, that's what they're asking you to do. Up here, I'm going to scroll for a second, then I'll come back to this. Up here, they gave you the two functions, and they asked us to put it together, and this was our answer. They're giving us this and asking us to work backwards and figure out what the two original functions were. Oh, you're going to love this, though. You're going to love this.
Okay. I'll put my
It is, because check it out. I'm just going to show you the answer to the first one, and then you're going to be like, well, that seems easier than it should be. All I need to do is remember that g is the thing that's going inside, right? The thing that's going inside is x minus 7. And what would I have to put x minus 7 into in order to make it look like this? That's it. You guys got it. Way easier than it seems. Now, last year, I had a student say, couldn't I just say f of x equals x minus 7 squared and g of x equals x? If I plugged x into this in place of x, wouldn't I get this? I was like, that is genius. That is super efficient. Lazy efficient? I don't know. You make the call. There's a bit of a judgment call in there. But this is another one. So there's not one correct answer to this. There would be an infinite number of correct answers to it. But just kind of look at it. Like when you look at this, kind of what do you see as the innermost piece? We want the innermost piece to be our g of x. What's happening inside of this function? I say x over 2 is what's happening inside of the function. So g of x is going to be the x over 2. And f of x, I don't know why I did the g of x first, but f of x is going to be the thing going on the outside of the function. 3 sine x. Right? And then if I did f of g of x, I would take this x out, put an x over 2 in its place, and this is exactly what I get. Okay? These ones, when I first saw it, I was like, what the heck are they asking me to do? And then I'll be honest, I had to look at the answers in the back of the textbook, and I was like, oh, okay, that's much easier than it seems. Okay, do you guys have questions? We skipped one, but I think we're good on the other 8 examples we did. Not checking work today. We have a review day on Thursday after our quiz, so I'll be checking assignments then. Yeah, I'll put the assignment up. Oh, yeah. Would you please? Yeah, split those up, whatever.